Hi, geometry students. Welcome to a new week. It is Monday, March the 8th, and we are going to be finishing up with Chapter 7 this week. So make sure that you are familiar with the lessons we did last week. It's not a terribly long chapter, and we will be having the tests next week. So be refreshing yourself with the flashcards. Okay, we are going to be looking at page 379. So turn there with me. And some of this should be familiar as we have seen similar things before. These have to do with proportions though, and not with equal triangles. So we're going to look first at a theorem, and it's right in your book, but I also have them on the screen. And this is the side-side-side similarity theorem, SSS. Similarity, not equal. So just remember that. If the corresponding sides of two triangles are proportional, then the triangles are similar. Remember, that doesn't make them equal, it just makes them similar. So if we look at the symbols, we've got FG is proportional to AB, GH to BC, and HF to CA. That then makes this is the similarity statement. Triangle ABC is similar, remember the little squiggly snake, to triangle FGH. Okay, let's take a look at an example here. It says in example 1, determine whether the triangles are similar. If they are similar, write the similarity statement that I just showed you and find the scale factor of triangle B to triangle A. So B to A, that means that we want to figure out what is B's proportions to the original larger triangle. So we go through and we first put our symbols, making sure that we've got everything correct. SU should be over PR. There we are, SU over PR. And that is going to equal 6 over 12. Remember to keep everything consistent. So then I do a little bit of fractional reducing and I come down to 1/2. Yay, very good. Then we're going to do UT as proportional to RQ. There's my little symbols. And I'm going to have 5 over 10. Then I do my little fractional reducing and I come up with 1/2. Again, so far so good. Then I'm going to do TS over QP. And that's going to be 4 over 8. Equals 1/2 again. So I can now say that PQR is similar, little squiggly line, to STU. But they also asked a second question, what is the scale factor? And the scale factor of B to A is going to be 1/2. So the B is going to go on top. The A is going to be on the bottom, 1/2. The little triangle is 1/2 the size of the big triangle. So always make sure you've got your proportions right. Okay, let's hop over to example number 2, and it says, is either DEF or GHG similar to ABC? So here we've got our ABC. This is our model triangle. They want to know if this little guy or this bigger guy are proportional in any way. So what we do is we go down and we write out our symbols. So first we start with the shortest sides. So I am going to have DE, and I'm going to make it proportional with the shortest side of the first triangle, AB. So I'll have 4 over 6. That comes out to 2/3. Then I'm going to find my longest sides. And here's my longest side on this one. FD is proportional to CA. And so I'm going to have 8. There's your 8. There's your 12. 8 over 12. That is also 2/3. Then I'm going to look at the remaining side. So I pick my short side, I pick my long side, and then just kind of the neutral one. And that's going to be EF over BC. So it's going to be 6 over 9. There's your 6, there's your 9. That too comes out to 2/3. So these two, ABC and EFD, or maybe I said that wrong, are proportional. So they're similar. We can put the little similar sign. So let's look at the next one. And I want to compare ABC with the larger triangle. So I find my shortest sides first. So over here, that's going to be GH over AB. So I'm going to have 6 over 6. That comes out to 1. Then I'm going to find my longest sides, which is going to be 14 over 12. So 14 over 12, well, that comes out to 7 over 6. I'm on a bad path at the moment. And then my remaining sides are going to be 10 over 9, the two in-betweens. And that will not reduce any. So because I have 3 different proportions, 1 to 1, 7 to 6, 10 to 9, they cannot be similar. So I have to leave that alone and I have to say no to the similarity. Okay, let's try some on your own. So, well, not really on your own. We're kind of doing these together since the answers are right here. So determine whether the triangles are similar. If they are similar, write a similarity statement. Now, what I would do is I would begin with my shortest sides. So I would begin with 12 over 8 or 8 over 12. Maybe 8 over 12 is easier. And I'm going to end up with 2/3 when it reduces. Then I'm going to do 10 over 15. And I'm going to have 2/3 with that one. And 12 over 18 is also going to give me 2/3. So yes, these guys are similar. Now, if you go through and you do the work, then you'll see how it comes to be. Then in the next one, we already know it's not going to be similar, but if you were to set up similarity state or proportional statements, I would have, looks like my shortest side, 5 over 9. That's not going to reduce at all. My longest side's 13 over 15. That's not going to reduce at all. And 12 over 12 is just going to be 1 to 1. So we know those are not going to be similar. All right. Here is my breakdown of those. Sorry, I forgot I had done this. But I did the breakdown on these. And so here are my proportional statements. And you'll see in the first one I came out with 2/3. And in this one I come out with all those weird measurements, 13 over 5, 5 over 9. All right, let's take a look at Theorem 7.3. This is side angle side similarity. So we're starting to see some things pop up that are very close to other theorems that we've learned. But those were for congruent triangles. These are for similar. So you've got different. You've got congruency and similarity. They're two different things. This one says if an angle of one triangle is congruent to an angle of a second triangle and the lengths of the sides that include those angles, that means on either side of it, are proportional, then the triangles are similar. So here we've got two different things going on. The angles are congruent, which means they're equal. The sides beside them, XZ and XY, MP and MN, are proportional. So those are similar. Let's take a look at how this works. So we have to determine whether the triangles are similar, and if they are, write a similarity statement. So you have a couple of checks or a couple of boxes you have to check here. The first one is, do I have a congruent angle? Well, they've given us that information, and 61 is the same for C and F. So I can check that box off. Then I need to compare the ratios of the sides. I need to see what they are proportionally. So I look at my shorter side, the one on this side of 61, and I'm going to have 5 over 3, and they've written that here for us. Then I'm going to look at the longer side, and I'm going to write 10 over 6, which reduces to 5 over 3. So these are proportional and my angle matches. So then I may write that similarity statement, triangle ABC is similar to triangle DEF. not too hard, I don't think. Okay, let's take a look at, to determine whether the triangles are similar, and if they are, write a similarity statement and explain your reasoning. So you're going to look at the bottom of page 381, and we are going to work on these. I'm going to have you hit pause, and I'd like you to do 3 and 4. That's all that's there. So do those and then pop back in, and I will work through them on paper for you, and then we'll be finished with this lesson. So hit pause, come back when you're ready. All right, if you're back, I assume you're ready to get started on these guys right here. And so I am going to pull up my first thing that I did. So I asked the question first, do I have an equal angle? H and M are equal, so I can check that box off. Then I'm going to look for my shorter sides, which happen to be 6 and 8. My longer sides, which happen to be 8 and 12. So now I'm going to put those in. And I happen to put the bigger one on top, 8 over 6, 12 over 3. And I ended up getting 4 over 3 and 3 over 2. So those first ones are not proportional. The sides are not proportional. So these are not similar. Now let's take a look at the next one. This is one where there are overlapping triangles, and you need to pull out the small triangle. And I think it's always much easier if you pull it out and have your two triangles sitting together. Just makes it easier to kind of think over that whole thing. So first we have to ask, do we have an equal angle? And the answer would be yes, because of the reflexives. You've got to give me a reason on this. Angle P equals angle P. So that would be yes. So now what I want to do is I want to figure out my side measurements of the big triangle and my side measurements of the little triangle. Now the big triangle, I have to put these together, the 5 and the 5. So my total's 10. And I have to put these together, my total's 6. And then I have 5 and 3. So now let's put that into my proportions here. And here I decided to go with the smaller one on the bottom. So remember, the 2 together came up to 10, so 5 over 10 equals 1/2. The 2 together came up to 6, 3 over 6 equals 1/2. So I have proportional sides and I have an equal angle. So that means PQR, or triangle PQR, is similar to triangle PST. That's what I want you to write for the similarity statements. Okay, that's all I have. We've gone through the whole lesson. You will do some homework on this, and however you divide that up. If you watch all of the videos one day and do the homework the next day, that's fine. Or if you're doing video homework, that's fine too. So I will plan to see you tomorrow for the next video, and I hope you have an excellent day.